Section 5.1, Part 2, Probability Rules. Lesson objectives. We learned two previous from Section 5.1, Part 1. In this video, we will learn three lesson objectives. Compute and interpret probabilities using the empirical method, compute and interpret probabilities using the classical method, and we're going to recognize and interpret subjective probabilities. Lesson objective number 3. There are three methods for finding probabilities: the empirical method, the classical method, and the subjective method. We will begin with the empirical method. Estimating probability using the empirical method is simply the relative frequency of that event. That is, you take the frequency of the event and you divide it by the total number of trials in the experiment. So empirical method involves performing experiments or using previous information. Let's look at an example. Pass the Pigs is a well-known game where players use these little pigs as dice. There are 6 different outcomes, and we are going to estimate those probabilities by using the empirical method. So a class of 52 students rolled the pigs a total of 3,939 times and recorded the frequencies. So here are each of the outcomes and the corresponding frequencies. So A, we're going to use the results of this experiment to build a probability model for the way the pig lands. We're going to estimate the probability that a thrown pig lands on the side with a dot. And last, part C, would it be unusual to throw a leaning jowler? Okay, we'll begin with A. So we take the frequency and we divide it by the total number of observations, and we get 0.341, and we do that for each of the outcomes. Part B, the probability of a thrown result in a side with a dot is 0.329. So what that means, if we were to throw this 1,000 times, we would expect about 329 to land on a side with a dot. Part C, a leaning jowler would be unusual. It is less than 5%. We would expect about 8 leaning jowlers out of 1,000 throws. So that would be unusual. Here's some more empirical probabilities. The probability of catching a ball at a major league game is 1 out of 564. The probability of becoming a pro athlete is 1 out of 22,000. Probability of drowning in a bathtub is 1 out of 685,000. This is what we mean by probabilities that are being estimated by using previous information. Probability of being struck by lightning is 1 out of 576,000. Being killed by lightning is 1 out of 2,320,000. Probability of being murdered is 1 out of 18,000. Of being audited by the IRS is 1 out of 175. Probability of having your identity stolen is 1 out of 200. And the probability of dating a millionaire is 1 out of 216. These probabilities are estimated by using the empirical method. Lesson objective number 4, using the classical method. The classical method of computing probabilities require equally likely outcomes. An experiment is said to have equally likely outcomes when each simple event has the same probability of occurring. So here's the formula for the classical method. You take the number of ways E can occur, and then you divide that by the total number of possible outcomes. And notice you do not have to perform an experiment. You just simply count how many ways the event E can occur and divide that by the total number of possible outcomes. This is stronger than the empirical method. Let's look at an example. Suppose a fun-size bag of M&Ms contained 9 brown, 6 yellow, 7 red, 4 orange, 2 blue, and 2 green. Suppose that a candy is randomly selected. What's the probability it's yellow? What's the probability it's blue? Comment on the likelihood of the candy being yellow versus blue. We're going to use the classical method for this one. Each candy has an equal chance of being selected. So we simply count the number of yellow and divide it by the total number. So if we look at the total number of outcomes, it's 30. There were 6 yellow, so 6 divided by 30 is 0.2 or 20%. The probability of blue is 2 out of 30, which is 0.067 or 6.7%. So the comment on the likelihood would mean yellow is 6 out of 30, blue is 2 out of 30, so that's 3 times larger. So you're 3 times more likely to select a yellow than a blue. Let's look at some card examples. So if we take the event drawing one card from a standard deck of 52 cards, what is the probability that the card will be black? Now we don't have to perform the experiment. We know that there's 26 black out of 52 cards, and that reduces to 1/2. If we look at the number of aces, there are 4 aces, so 4 out of 52 reduces to 1 out of 13, or 0.077. The probability of a black ace, that can happen 2 ways: ace of spades and an ace of clubs. So that reduces to 1 out of 26. Ace of spades, there's only 1 ace of spades, so that's 1 out of 52. One-eyed jack, there's 2, so that's 2 out of 52. Face card is a jack, queen, or king, and each suit has 3, so 3 times 4 suits is 12. 12 out of 52, which reduces to 3 out of 13. A number less than 5, well, that would be 4, 3, or 2, and each suit has them, so 3 cards times 4 suits again would be 12 out of 52, which would reduce to 3 out of 13. And the probability of a club, there's 13 clubs out of 52, and that reduces to 1/4. Okay, so if you need to verify these, this is the sample space for cards. Let's look at our next example. A pair of dice are rolled and the top faces are recorded. We want to know what's the probability that the sum is a 7, the sum is a 2, the sum is not a 2, and the sum is more than 12. The sum is a 7. That can happen 6 ways. So we have 6 out of the total number, which is 36. Now if you need to verify this, on the next slide we will have the sample space listed out. Next, the probability that the sum is a 2. That can happen only one way: a 1 on the first die and a 1 on the second die. So that happens 1 out of 36. The sum is not a 2, so if we verify this, this can happen 35 ways out of 36. And the last one, the sum is more than 12. Well, 12 is the largest, so that's a 0 out of 36, which equals 0. This is impossible. So here is the sample space for the dice. Is there a relationship between the empirical method and the classical? And the answer is yes. This is known as the law of large numbers. And basically what this says is, as the number of repetitions of a probability experiment increases, the more you do it, the proportion in which a certain outcome is observed gets closer to the probability of that outcome. So as you increase the number of times you do the experiment, that proportion gets closer and closer to the theoretical probability. So here's a graph of flipping a coin, and we see a lot of variation here early on, but as we increase the number of times that we flip the coin, the more this experimental probability gets closer to the theoretical probability of 1/2, 0.5. Lesson objective number 5, subjective probabilities. This is used a lot in sports betting. What is the probability that the Reds are going to win the World Series this year? Or that the Bengals are going to win the Super Bowl? Or that the Celtics will win the NBA championship? These types of probabilities cannot use classical, and we cannot use empirical. So we have to use subjective. And subjective probability of an outcome is the probability that's obtained from personal judgment. For example, an economist predicts that there is a 20% chance of a recession next year would be a subjective probability. In his fall 1998 article in Chance magazine, Al Stern investigated the probability that a particular horse will win a race. He reports that these probabilities are based upon the amount of money bet on each horse. When a probability is given that a particular horse will win the race, is this empirical, classical, or subjective? Clearly this is subjective because it is based upon these people's feelings about which horse will win the race. The probability is not based upon an experiment or counting equally likely outcomes. Here's the ratings and suggested problems. Thanks for watching.